Okay, we're continuing chapter 4-2 today with example 3. A prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. So, here's the house. This half of the house and that half of the house got brought on trucks. They put them down, they attach them together, and all of a sudden you have a house. Alright, that's how it works. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? Explain. So, main idea of this question is, this house, half and half, will be on two different trucks, and we need to make sure that it can fit under a 17-foot high bridge, right? So, bridge is 17 feet high, we need to make sure that the top of the house does not hit the bridge, or else we have half a house laying on the highway, probably traffic backed up for miles, right, all kinds of bad things happening. So, can you all see that the length or the height of this bit of the house is 10 feet? You can all see that fine, right? We're going to assume it's a perfect rectangle. We assume the people building the house put lots of time and effort into this to make sure it's a beautiful rectangle here. So this right here and here and here is a rectangle. So if that's 28 feet there, would we all agree that's 28 feet right there? And if we take a look at the roof part of the house here, we have a 16-foot roof and a 16-foot roof leading us to an isosceles triangle for ABC, right? So what I'm going to do over here is I'm going to draw a triangle ABC over here. I'm going to give myself a little bit extra room. So I'm going to draw a triangle ABC, putting in what I know about ABC. So I've got A, B, and C. And we got a 16-foot length for AB, a 16-foot length for BC, and a 28-foot length for AC. Okay, going back to my isosceles triangle vocabulary that we talked about yesterday, or actually on Monday, the two sides that are equal sides in the isosceles triangle are called the legs. The non-equal sides called the base. The base angles are equal to each other, and the vertex is opposite the base, right? So B is the vertex of this isosceles triangle. And if you look at the picture, they've drawn this altitude in, right? So that B down to the base right there. If we draw that in on our figure right here, I'm going to draw a dashed line to represent it. That's my height of my triangle, right? And the height of any triangle is usually drawn in perpendicular, so we'll make that perpendicular. They mark this angle equal to that angle up on the picture. You can see that there. And I already know that angle A and angle C are equal to each other. So if you notice these two triangles, the hypotenuse 16, the hypotenuse 16, all the angles are the same. These are congruent triangles, right? Which means that this piece right here and this piece right here should be the same length. In general, let me give you a rule about isosceles triangles. If you draw the vertex to the base altitude in an isosceles triangle, so the altitude, the height, goes from the vertex to the base perpendicular, it is always bisecting the base. So the altitude bisects the base. So if this is 28 feet across, this bit here is 14 feet, and this bit here is also 14 feet. My figure is not drawn to scale. That's why this one looks a little shorter than that one, but pretend it is. It's marked as such, so we're going to use the property, geometric property. So if I go from the vertex to the base perpendicular, it always cuts the base in half. By cutting the base in half at a right angle, notice I've created a right triangle. I've created, let's just call this point here D to give it a name. Triangle ABD is a right triangle. Triangle CBD is also a right triangle. Take your pick, doesn't matter which one. If I focus on the right triangle part of this, let's look at this one here. This right triangle here. H is a leg, 14 is a leg, 16 is a hypotenuse. We've already learned Pythagorean Theorem. Previous years we've also dealt with it this year. But I know leg squared plus leg squared is equal to hypotenuse squared. So again, I see a right triangle. I see two sides known, one side unknown. So I apply the Pythagorean Theorem to find what I don't know. If I work this out, 14 squared equals 196. 16 squared equals 256. If you've not yet memorized all your numbers, 1 squared through 25 squared, you should. It saves you tons of time. Got this little test called the ACT happening in a couple of years. The more time you can shave off that, the better. Knowing your perfect squares is helpful. So 196 and 256. If I subtract the 196, I get h squared equals 60. So h is going to equal the square root of 60. Now, depending on what I need to know, that may be enough information, it may not. I might need to actually evaluate that. I might need to get a decimal approximation of that. What we need to know is, will this truck fit under this overpass, right? We got a bridge, 17 feet high. The house is sitting on top of a truck. We'll pretend that's not even happening. Let's just pretend the house is being dragged right along the ground, all right? Because again, if this is on the truck, that's already off the ground a little bit, right? Can we all buy that? So we got the truck, there's the truck bed, truck wheel, so the house is, so there's some height there too that we aren't even focusing on, but we'll pretend that's not even happening in this problem. We focus just on the height of the house part. From here to here is 10 feet, right? From here to here is what we have as the square root of 60. Now, what's 7 squared?
40.
And 8 squared? 64, right? So I know the square root of 60, even though I don't know the exact value, but it's between 7 and 8, right? Something bigger than 7. Can we all buy that? So whatever this is, it's bigger than 7. So this is greater than 7. Right? So if I take 10 feet, add something greater than 7, it's going to be 17 point something feet, right? The overpass is 17 feet high. Can we fit under it? Sure can't, right? So again, I can evaluate that. I can get the exact answer. I wrote a decimal answer, square root of 60, square root of 60, 7.75. The height from the bottom to the top of the house is 17.75 feet. All right. The question simply asks, should the trucker plan a different route? Can he fit under the bridge? Sure can't. So should he plan a different route? Sure should, right? So that's all we're doing. So we're answering the question. Trucker should take a different route. Explain. The house does not fit under bridge. Everything they asked me to do. Should we do it? Why?
So is the height of the house, is that part of the answer also?
I mean, the height of the house shows you that it's not going to fit, right? So, I mean, if I was just circling final answers, what's written in black is my final answer to the question they asked me. I had to find the height of the house to be able to answer the question. So it would be somewhere on your paper, maybe not circling that, but it doesn't hurt to circle extra stuff.